Never had the colorblind person run the green button. So my name is Steve Asseltine. This is Captain Mike Biddy. We're here to talk about today how we're using biometrics and some predictive machine learning to basically help us understand how firefighters are sleeping. So here are the facts. We know the 4 things on the left are happening. We also know that lack of sleep impacts those things. But now we have devices out there that can provide us with biometric information that we can now utilize to help us learn, and I mean help start to learn, how firefighters are sleeping and how that's affecting their performance. So potentially the recliner, as seen here, may be the most important piece of personal protective equipment in the firehouse today. So how do we go about this? Well, we bought boom straps for a bunch of our people, and then we started to look at that. Here is a screenshot from one of those people for one day. And as you can see, they only slept for 3 hours. That's 26% of what they were supposed to get. But importantly, on the very lower left-hand side, the quality of sleep, the sleep that they need to really recover, they only got an hour and a half. The next step is going into the group setting. And this is all of the people participating in our study. And what it shows on the lower right is that 17% of the people on this day, this is both on and off duty, were in the red, meaning that they're not adequately recovered to perform at the highest level. So now we're digging into the deep stuff.
Oh yeah, here we go, the nerd stuff. Everybody shake off the inhalers. So we put our whole platform together. We use our ESO platform for our RMS. We have our staffing platform with Vector. All of that information goes into our Azure platform. We also have the biometrics, which Chief talked about, coming into our information. And we also got with Dr. Billings to start to understand and quantify the perception of fatigue and see how all of that plays together with the ultimate goal of creating some sort of dynamic staffing information, or more importantly, how do we build policy that promotes better sleep and recovery for our people. So we used a progressive modeling approach. We started with very simple predictive regression modeling, a couple different models. We blended them all together, and then created an average of average. That created just a cause and effect relationship. If this, then this. Then we took it up another step, and we're pulling in more biometric data that is narrowing our variance, improving our modeling, and creating better, more accurate predictions and more, precise predictions as well. So then our next step is we're actually starting to build neural networks so we can understand kind of the interrelatedness of different variables. And that's gonna allow us to start doing a better job of creating predictive biometric outcomes for different policies. And we created this cute little image. It kind of has Stranger Things vibes, but that's all. It's intentionally complex because as we're looking at all these different inputs, they are complex. So here's kind of the sausage on this deal. All of these cute little Skittles over here are actual humans that put into our system. On the left side here, we have restorative sleep in minutes, and then our night commit that came from our RMS. So we have multiple regression models that we'll put together, and then it creates kind of this blended projection of what's gonna happen to these people on engine 1 based on how many minutes they're assigned to calls. So we take this, and what do you do with it? So here we go. This is what we provide our district chiefs. So they wake up after a beautiful night's sleep, they take the cucumber slices off their eyes, and they go over, get themselves a cup of coffee, and start looking at their staffing platform for the night. So we can see here how long different calls or different resources of our 39 different resources hit some of these thresholds that we've pre-identified in our system. It incorporates UHU, how many calls they ran the day before, and as well as how many night commit minutes they had. So if you look over here, this is our heavy rescue. They were up for 2 hours and 15 minutes in the night. They went out 7 times, and so we can predict that they exist somewhere in this box here. Well, that's not super accurate yet, but as we keep feeding this data, all these little blue dots are people who put in, we can start to understand where they are. And this is human variability here. Everybody tolerates, biometrically, people tolerate these conditions a little bit differently. So as our model grows and learns, this variance will start to narrow, and we'll get a really good idea of where people are. And we can provide this information to our staffing our staffing decision makers to say, who needs to go into the penalty box? How are we going to build policy to support these people to help them make good decisions?
So the other thing we wanted to achieve with utilizing the Whoop platform is we wanted to have something that supported firefighters now. And the Whoop platform shows that 50% of the users actually get better at sleeping when they use the app. So there's 4 screenshots here. The one on the left is really an important one. That's a person, one of our firefighters, and the 2 in the lower or right in the middle are where that person is not having enough adequate rest to perform, quite frankly. That's when they were on shift. The other 2 in the middle were just some other metrics that you can monitor, and the one on the right is Captain Vinny here kicking it on the spin bike. So,
thanks. Okay, so if we had hypothetically a division chief of risk management, what would that person say? So how are we going to use this information?
So in the future, here's what we're looking at. This can influence our deployment and staffing models, both in a dynamic and a static environment. We can also look at the situation that existed when accidents, injuries, or medical errors occurred, and we can create policy or we can create stuff to basically help us fix that and not repeat those mistakes. We can also implement strategies, look at the data we have now, and then compare it with what we have after so we can accurately know exactly if we're having the impact that we want to have. All of this influences firefighter health and the service levels that we provide to the community. So let's get to work. So here's a little call to action. Sorry, Doc, but with NERIS, we're collecting a lot of stuff. What we're asking is let's include biometric data into the schema now so we can start understanding that very early in the future. And Dr. Jenke, thanks for stepping up to take on a multi-year project for researching sleep in firefighters. West Metro will be sharing our data set with other researchers so that we can help contribute to future learning. And that collaboration that we all do, it's not just a word, it's a responsibility so we can affect future generations in a positive way.
Okay, here's our information. Here's a link, QR code to our full slide deck. We partnered with the Yale School of Public Health to start putting all this together. It includes our methodology and our grant funding. And then also, I got to throw this plug out there. Tomorrow, Dr. Coppola and Chief Oates and I are going to kind of do a cannonball into the deep end of the wearables with the ethics, legal considerations, how the heck do you start one of these programs, and what do you do when the dog catches the car? So if you want to meet us over there tomorrow, we'll get really weird. So, all right.